Okay, now let's just try some BJT biasing again. But in this case, we will assume base voltage is 6 volts. And VB is 0.7 volts. So let us proceed. Now, best is to start off by finding VE, then finding IE, finding IC, and then finding IC, and then finding VC. So that's how I will proceed in this case. So let's start off with VE. So VE must be VB minus VBE. This will give me this voltage here. Let's proceed. So that is 6 volts minus 0.7, which is approximately 5.3 volts. And now I have to find a current going this way, which is basically VE minus ground over the emitter resistance there. So 10 to the power 3. So that's 5.3 over 3.3 milliamps, because this will be milli, you bring it up, it becomes a negative exponent. So let's see, 3.3, so that's 1.6, I believe it's 1.61 milliamps. Okay, then our next step is to find IC. IC is related to IE in this relation, IE, alpha IE, where alpha is basically equal to our common gain, our common emitter current gain, plus 1. In this case, we said it was 100, which I should have made clear earlier, which is approximately 0.99. So therefore, IC should equal 0.99, and my IE we said was 1.61 milliamps. So times 0.99. Put that in the calculator. It's 1.59 milliamps approximately. And now I need to figure out what VC is, which is our collector voltage at this particular node. And yeah, we could just, it's very easy to see. So it's 10 minus a drop here, 10 minus 4.7 times whatever the current is going down here will give me the voltage here. Hopefully that makes sense. So let me just write this down. So VC should be by VCC, which is our supply, minus IC, collector current, multiplied by RC, which is our collector resistance. Okay, it just makes logical sense. So 10 we said it was, and here we already worked this out as 1.59 milliamps multiplied by our collective resistance is 4.7 kilo ohms. Kilo and milli cancel out. Let's see what we have. 59 multiplied by 4.7. So approximately 2.527 volts is equal to my VC. Now I have to determine an important factor because I assumed active mode. Let's see if this assumption is correct. To see if this assumption is correct, we have to figure out what the value of VCE is. The value of VCE is VC minus VE, and my VC we said it was 2.527 minus 5.3 volts, right? And of course this should be impossible because you can't go from a lower potential to a higher potential just intuitively. We should get a negative value here. Just to complete the solution, it's approximately minus 2.773. It's not in active mode, therefore we assume saturation. We have to rework this thing in saturation. In saturation, we have the following assumption: VCE approximately 0.2 volts. Right? We have to work with this particular assumption. So our working for VE, which is this guy here, remains the same, namely 6 minus 0.7, 5.3. The only catch that we have in this case, the only catch that we have in this case is collector voltage, we need a new way to figure out what collector voltage is. And of course, because the V is still the same, that means the current should still be correct. So we said, what did we say? We said that VCE we assume to be 0.24 volts, and this entails VC minus VE is 0.2 volts. This entails that I can figure out what VC is, right? By going VE plus 0.2, right? So 5.3, 0.2, 5.5 volts is equal to my VC, and therefore my IC should be my power supply minus the nodal voltage, VCC minus VC over my resistor, 10 to the power 3. Just to visualize this in case you cannot follow along. So this power supply minus this divided by the resistance should give me my IC. Okay, makes sense. And so that should be 10 minus 5.5 over 4.7. And this should be, of course, in 10 to the negative 3. Make this negative. And what do we have? And we got something like 1.05 milliamps for the collector current. And it's in saturation mode. Oops, my bad. Actually, it's I actually made a mistake here. It should be minus 4.7, not minus 4.3. My apologies for that. So in truth, it should be approximately 0.96 milliamps. A small error there, and that's basically it. And of course, here I could also work out the base current. So the base current, now I remember the total current through the BJT should be IC. So going back, just to visualize this, the current through the emitter should be the current of the base, the current of the collector. Combine these two guys, right? Kirchhoff's one of Kirchhoff's laws, and we should get a total current going down this way. So therefore, my IB should equal to my IE minus my IC. And what was my IE? So maybe it was 1.61, I think. And then the one that we calculated previously, 0.96, and of course, this is all in milliamps, so don't forget the units. And we got approximately 0.65 milliamps as a current going into the base. And yeah, that's it.